Hey everybody, this is Larry. This is me going Q4 of the weekly contest for Dirty. Count the number of arrays with K matching adjacent elements. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. This one in concept is, or not in concept, but in implementation is simpler than Q3. So a lot of people, or a lot more people got it for Q4 than Q3. But I don't think this is easy. It's just very specific knowledge. And I end up taking about 14 minutes on this one. And honestly, my first read was that this was going to be dynamic programming with some sort of optimization. So I actually did a n cube or n times m times k dynamic program just to kind of get my feel into things. Revisiting it, you could watch that live, and obviously, given that n and all these numbers are 10 to the fifth, it's not going to be fast enough. And I didn't really see a way to optimize it, right? And then the next is just combinatoric. I think the way is a little bit so that also one thing about that one thing I have to talk about is just modular inverse, right? I'm not gonna go over this, but please Google it and kind of look for it. But the idea behind modular inverse is that you're able to calculate a fraction in a mod, right? Or division in a mod, which I guess is the same thing. But basically, because if you think about mod rows, right? You could do like 8 times a mod b times b mod d is equal to a times b mod, something like that, right? But then if you try to do fractions, how are you gonna do it, right? Like, question mark. So modular inverse basically answer this, essentially. So that's really what that means. But yeah, and the reason why you need this is because we are going to do factorials, because this is a combinatorial problem and there is a choice, right? Or yeah, like n choose k or whatever. And the way to think about this is probably better with visualization. So let me bring up the drawing board. Right. The idea that I thought about is, and there are a couple of ways, and I kind of not necessarily took the shortest route, but I think these things for me honestly is sometimes kind of tricky to prove correct, but other than like proof by AC, just because combinatorial, there's so many ways to do it that that sometimes it's tricky. But the way that I thought about it is that, okay, well, count the number of, we break it down a little bit, right? Which is that we have k exact index where it is exactly the same as the previous thing. So let's say we have, I don't know, 5 numbers, right? So we have how do I even, so let's just say, I'm just going to say yeah, ooh, that's not drawing thing. Like ooh, why is this so thick? What am I doing? Hang on. Technical difficulties, friends. Okay, hopefully this is a little bit better. Okay, yeah, so we have this, right? And then we want exactly terrible handwriting, but we want exactly k things where they're the same. So then really the only given there's 6 items here, but let's just say we dot it to a to the n, then with for n items there are n minus 1 what I call slots, right? And slots are basically in between numbers, right? So then now you have basically a sub 0 and maybe a choice, a sub 1, maybe a choice, right? And what I mean by that is that the choice here could be same as previous and different from previous, right? So there are 2 choices, but in total, I'm misspelling it. Okay, fine. Yeah, you get the point. But in total, there are k of these, and because there are n minus 1 of these spaces to choose from that we want the same, so then now we have n minus 1. How did that even come out like that? N minus 1 choose k, right? So that's the first part, right? Is that, okay, the k components, we choose k of them to be exactly the same. Okay. Now we have to incorporate the m. Well, what happens if they're the same, right? The two things. If they're the same, then there's no choices in the next number. But if they're not the same, there's m minus 1 choices, right? M minus 1, because if they're not the same, then one of the numbers you cannot choose, so it's n minus 1. So yeah, and then of course in this case, how many numbers, how many of these do we have? Well, we have k of these, k of them are the same, so that means that n minus 1 minus k are different, right? I don't know what I just did. Right? So that means that we have, so this number times m minus 1 to the power of, I went out of space because I'm a noob. Hang on. I do have the magic power of moving it over though. Oh, whatever. Right? M minus 1 to the power of n minus 1 minus k, right? Because that's the number of different, right? So this is the same. This part is the number of components that are the same, right? We choose k of them to be the same, but also that means that n minus 1 minus k are different. And for each of those, we have m minus 1 choice, and for each of, so then we have this. Okay, so we're almost there at this point. The only thing that's different is that, well, we have to choose the first number, because the first number, well, it could be anything, right? So any of the m's, so then we just times m, and that's pretty much it. So this is the formula, and I think with some practice with combinatorics, it's not too difficult to get. Not to say that it's easy, but it is possible, right? And then now, and that's basically what my code does, is that translating that formula, right? I even kind of wrote this for myself, honestly. But yeah, here we process, because we call that, you know, for any given n choose k is equal to n factorial over n, or over k factorial times n minus k factorial, right? So that's it. Pretty straightforward in terms of understanding. Yeah, that's pretty much it, right? And for this part, we need n up to n factorial, and then on the bottom we want 1 over k factorial, and also 1 over n minus k factorial, which is why we need this modular inverse thing that we talked about. And here we processed everything up to the max number, which is 10 to the 5th. So at that point, hopefully it's straightforward. Well, I mean, in the for loop. And here, you know, this is just factorial stuff. We modded, remember, and this is 1 over I factorial, right? Yeah, 1 over n factorial, I suppose, which is 1 over I times n minus 1 factorial. So that's basically what I have here. And yeah, and here I just wrote it a little bit differently, which is slots is equal to n minus 1. So we have n slots to choose from, or n minus 1 slots. This is the fraction that we talk about, which that is the n minus 1 choose k, right? So that's the factorial over k factorial over slots minus k factorial. Just drop my pen. And this part, do have it on screen, right? Okay. Yeah, and this part, it is just m minus 1 to the number of slots where it is not the same. Remember the mod is part of the power, because you do one mod power, otherwise it gets too big. And then times m, as we talk about the choice for the first number, right? And that's pretty much it. You can get a little bit sloppier with Python with mods, because this is mod, this is mod, this is mod. So it's at most like mod to the 5th or something, which is not that much of a thing I worry about. Though you can also mod more if you like. But yeah. But this is also once per input, so you know you're not gonna need that much of an issue. But with another language, you may have to mod quite a bit more, or just to have a class, I suppose. But yeah, that's pretty much all I have for this one. I think the hard part about this one is kind of just enumerating them in a good way. I myself is not that strong about it, so wasn't super confident, to be honest. But yeah, that is all I have for this one, though. Let me know what you think. Thanks for watching, and you can watch me solve it live during the contest. Now, give it a submit. Hopefully it doesn't time out. Okay, that wasn't that bad. I don't know. I don't know why. Is the virtual leaderboard doesn't work anymore? That's actually not great. Let me ask on the Discord real quick. How do I get the virtual leaderboard on Working. Or can someone give me a virtual? Thanks. Okay, I guess we'll come back to it. Anyway, okay, Q4. Okay, count the number of ways with k matching adjacent elements. Okay, and k good way. Okay, a good array is 1 to m. Okay, this mod, right? Exactly. K index is I where the adjacent elements are the same. Okay. And n is up to 10 to the 5th. K is 0. Okay, so the naive thing would be to just do okay, let's write out the naive. I feel like I am really bad at these. But we have the index and then the last element. Right. Technically the last elements don't really matter, but for the purpose of this, for symmetry reasons, maybe. But then also the number of good, right? K. So that's not or left. Right. So then if you write it this way, it's gonna definitely be too slow. But we'll try. So index is equal to n. Right. Then we return 1 if if left is equal to 0, we return 1, otherwise we return 0 actually. What is m? M is the number of numbers, so then we have to do the for I don't know, whatever, x in range sub m. It wants him from 1 to n, but it's fine, we just do it from 0 to m minus 1. So then if last is equal to x, then count left plus 1, last I guess x, and then left minus 1, and left is I guess. Otherwise just index plus 1 x. I guess this is a little bit awkward actually. I think this is the actual loop. Else then we just left, right? Yeah. And I think that's it in theory. I mean, it's not gonna work because the constraints don't make sense, but then maybe this, I feel like recently I've been really bad at these kind of dynamic programming optimizations. So I feel like maybe this will kind of let me you know, okay, 361. Okay, I'm wrong. So at least like we have to do this part right. Why do I even get this one wrong? Oh, because I assume the first number is 0. So are we undercounting then? Yes, we are. That's good. Okay, then yeah, for I in range of m, right? Then okay. I mean, I definitely am watching it because I know that this is not my final response, so that's kind of thing. But 6, 12, 2, that's not right, right? Why is that? Okay, so that's not good either. I thought that would be it. Oh, I guess the first index is, I think actually I messed that up. It should be this, or it should be this. Maybe that's a little bit better. Okay. Well, now we don't need the for loop again. And I need to also do that silly trick that people always tell me to do, but maybe just want to see that this works. Okay, so now we finally got the actual working thing. Okay. Yeah, I'm beginning to think it's the old UI thing. I don't know how to fix that actually. That's not great actually, because I don't know my times. Okay. Anyway, I mean, of course this is gonna be too slow. There's a lot of symmetry in this, but it still depends on the numbers left and k, which even if you reduce a dimension, it's still too slow. Because is it just like a choice thing? I guess it's just mathematics, right? Because basically you have n-1 places to choose k, right? So this is going to be n-1 choose k, except for the number of places where you don't choose k, you have m, something like, yeah, m-1 choices or something. So then, yeah, maybe that's it, right? I don't know if that's right, but I guess the DP I don't see a way, honestly, afterwards. But okay. How do I write choice again in a good way? n-1 choose k in Python with mod. I guess it's just factorial and factorial thing, right? Okay, fine. Okay, fine. Yeah. Yeah, okay. Toyo to something like that, right? Oh, fact, the new one. Oops. Whoopsie daisies. Okay. 1, 2, 3. Okay, whatever. That looks about right. Okay. So then now we want n-1 choose k, right? So that is just going to be, oh, I need to mod this actually. That's pretty bad. I forgot. I think I'm trying to think, because I think like people has told me a better way to write this. Maybe this is wrong actually. Yeah, that's not great actually. I think that is. Man, I'm so rusty today. Okay, it's one of the. Maybe it's just what's it called? I mean, we could do another way, which is because I'm actually worried about the correctness about this, but yeah, times power of I minus 1 mod, right? think that's a little bit better. And then mod this, of course. Okay. Yeah. Okay. And maybe just 0.5. Can't believe I'm spending too much time on this, but that's okay. That looks about right. 1/2, 1/3, or 1/6 rather, or 1/3 from the other one. Okay, fine. So then now we have, so slots is equal to n-1, right? And then now we want to choose k of them. Yeah. So then now we have what is it? Just slots factorial over k factorial over slots minus k factorial. So that's the number of things, and then we times that by m-1 choices, because it has to be any other number exactly. So then that is number of slots minus k, yeah, times facts of, no, not just slots minus k to the power of m-1, remember to mod, and then we just return this modded, right? 2, 3, 4 is really not right. What am I going wrong on this? Okay, I mean, at least it's wrong for small cases, so that's good, because I can dissect this. Okay, so k is equal to 1. 3 numbers, you have 2 slots, right? So this is 1 to the power of 1 to the power of one other thing is 1, so you have no choice. Okay, that's fine. 2, 1, 1. Yeah, let's just put it up. Okay, slots k, slots minus k. So 3 numbers, we have 1 choice, right? 2, 1, 1. Yeah, that sounds right. So 2, 1, 1. So we have 2 as the answer. What have I answered? 2, 3, 4. 4 is actually more discerning, because I think 4 doesn't make sense here. This one I think I can adjust by having times it by m for the first number. So it's actually this times m, I think, is probably a little bit better. I get to be sloppy in the I get to be sloppy with this because Python math, big int math, it's a little bit slower, but it's fine. Okay, but then now this 8 is interesting. Why is it 8? Well, it's the first time. Oh, k is 0. So then you have 4 different choices. No, you have 2 different choices. Wait, what? So 4 times 2 minus 1. Did I do this wrong? m-1 choice per slide. Okay, I did get this wrong. Okay, that's an easy fix though, so I think that's great. I'm really bad at math apparently. 4, 2, 6, 2. Okay. Whether this is right, we'll see, but it looks okay for these numbers. I mean, I could imagine a lot of people did it very quickly. I don't know if this is so slow though. I mean, I guess what people can do, I mean, this is fine, right? And unfortunately, you know, I don't know what my ranking is. Can someone... Okay, I'm asking on Discord if someone could give me a link to the virtual contest things. I don't know what the link is. So I guess I can come back to it, but you know, but we did pretty okay. This one was pretty straightforward. I mean, I don't know what the timing here is. I think I should have took it outside. 7 seconds is a little bit awkward, but that's a easy fix, and that's a terrible fix that they make you do, honestly. But that you could just put it outside here like that, right? And then now we just set it to, what is it? That's fine, right? Yeah. Oops, mod. Where's my mod? Okay. I mean, I guess I could pause, but it still won't let me know my results, right? Which is a little bit awkward. Okay. Yeah, and then now, yeah, that's just silly, but okay, Leetcode. Yeah, I mean, I think this is roughly it. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's contest, or this virtual contest, this explanation, the problem, everything being trained. Yeah, stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.